Actually, it was a demotion, and it wasn't that short term. It was 5 years before I got my stripe back. So that was a painful, very, very, very painful 5 years. But the good news is that having gotten my stripe back after 5 years, I then quickly became a distinguished engineer, and then last year I became a technical fellow. Technical fellow is kind of a big deal at Microsoft. We have over 100,000 employees. We only have 22 technical fellows. Actually, the majority of those are really vice presidents, people with 100 or 300, 700 people working for them. There are only 8 individual contributor product-focused technical fellows, which is what I am, and Mark Rusinovich is another. So out of 100,000, there are only 8. So it worked out in the end, but I will tell you it was difficult in the middle. Anyway, so today I'm going to talk to you about the DevOpsification of Windows Server. I'm a technical fellow in charge of the Enterprise Cloud Group. We have Windows Server, Azure Stack, our management products, and Store Simple. And today I'm going to talk about the server. Now, I have 30 minutes and 44 slides. Now, in the professional speaking community, they have a phrase for this, and it's called a stunningly bad idea. So I'm gonna go quickly, so you're gonna have to pay attention, like no drifting off, okay? Okay, so here we go. Here we go. Okay, so what is DevOps? So I attend a lot of discussions. Michael gave a great description of DevOps. Nathan gave a great description yesterday. A lot of DevOps meetings, this question, what is DevOps, often dominates the conversation. And whereas there's a lot of really good exchanges that go on, rarely do I find someone at the end of that saying, well, that settles that. Now we know what it is. However, in the discussion, there's almost always a consensus that DevOps is about culture and about processes. Culture and processes. And specifically, and a lot of people tend to get very adamant about this point, DevOps is not about tools and technologies, it's about people and processes and culture. But this is wrong, right? This is wrong. Indeed, critical tools and technology play a critical role in DevOps. Indeed, culture and processes are the higher order bit, but technology plays a critical role as well. And specifically, tools and technology can make DevOps easy or hard. So here's what I'm here to say, is I've spent a lot of time on Windows Server 2016 to re-architect it, to make DevOps easy. Windows Server 2016 is the largest architectural change in Windows Server since really NT. I mean, it's a fundamental re-architecture change. Now, if you're sitting there saying, oh my heavens, what's that mean for me? The answer is, if you want to continue to treat Windows Server the way you used to, you can. This is an additive thing, and you'll see that. So what's the problem? The problem is that Windows Server has been silent on this interface between developers and operations, right? There really was no architecture between the handoff between these two groups. And so we let 1,000 blossoms bloom. Yeah, do it whatever way you want to. Of course, the problem with that was that 1,000 conflicts also bloomed. Because there wasn't this well-defined, here's how you do it, some people wanted to do it this way, some people wanted to do it that way, 1,000 blossoms, lots of conflict, okay? Windows Server 2016 resolves that interface by resolve that conflict by defining the interface between developers and operations. In particular, we believe that there are 2 DevOps models. There's the traditional DevOps model that's out there today, most people are using, and this is an emerging one based upon containers. Containers kind of, I believe, fundamentally repartitions the work and changes who is responsible for what. In particular, that a bunch of things that used to be done by the operations staff on instances of live running instances are now done by developers in the development process. Okay, so we resolved the interface for that. So now the question is, why did I get the go-ahead to make such dramatic changes, right? I mean, this big Windows Server, very successful business, very successful business. Guess what? Very successful businesses, they don't like big change, and yet Windows Server 2016 is a big change. So why was I able to do that? And the answer is the cloud. okay, the cloud, right? The cloud fundamentally changes everything, and to succeed in the cloud, you need to be small, you need to be fast, you need to be super, super secure, and you need to be great at DevOps. Now, just to be clear, lots of people are doing DevOps with Windows, being very, very successful. We're just going to make it easier with Windows Server 2016. So there's quite a few things, components to that story. I'm going to talk about just a few of them here because, as I mentioned, I only have 30 minutes. So the first, as you can't read there, is componentization. Okay, so componentization is all about getting the right configuration for the task you have at hand. Okay, so Windows Server 2016, there are 3 major deployment options. The first is what we call server and a desktop, right? See what I did there, server and a desktop? It makes me sad, okay? So anyway, so server and a desktop, this is the, you like that one? This is the full thing. You get the full client, you know, you get the browser, you get Cortana. You can say, hey, Cortana, please start IIS. You know, it is the full desktop experience. And this is optimized for people who get a lot of value in having complete correspondence between their desktop client and their server, right? So this would be, think about small businesses, small to medium businesses, but then also for remote desktop experiences. Now this is a little different than in the past. This is really the desktop, the client experience with server components added to it. So the relationship is very, very tight with the client. You get a great client experience. Then we have Server Core. Server Core is for our traditional data center workloads, and this distinction's been available for quite some time. And now we have a new deployment option, and that new deployment option is called Nano Server. Nano Server is a dramatic refactoring of the operating system. With Server Core, what we did was we took server and a desktop, and we started whittling stuff off of it, right? And we got rid of the GUI and got down to here. It's still pretty large. With Nano Server, I took the opposite direction. I said, hey, what is the minimal installable, bootable piece of code? And then what components do I need to get to a minimal server experience? And then everything else is componentized after that. And in fact, the components can be out on the web. So you can be there and say, hey, get me the latest version of some IIS, and we'll get it, the latest patched version from the web and download and install it on that. So this is really optimized for the cloud, right? It's your next generation environment. This is where you want to target all your new applications, and it's optimized for containers. In fact, containers in this came about at the same time. That's not a coincidence. In order to work and manage Nano Server, we had to have a new version of PowerShell. .NET, PowerShell is based upon .NET. .NET, the full edition, basically brings in everything. There's GUI libraries and all that, and that would not work for Nano Server. So there is a new version of .NET that works on Nano Server that's called .NET Core. They did the same thing we did. They said, hey, what's the very smallest component? And then they make everything else optional packages on top of that. We refactored PowerShell to work on top of that, and they call that PowerShell Core. Come on, baby. Okay, so this gives you PowerShell version 5. PowerShell version 5, major release, major release. If you've been staying there on PowerShell version 2 or PowerShell version 3, you really want to look at PowerShell version 5. It is a major release. In particular, we released desired state configuration in an earlier release. This release, it was one of the primary investments, huge investments. We really kind of took it to critical mass and a bit beyond that. Additionally, massive investment in security. This is a very secure environment. Helps you find the bad guys, not just protect against the bad guys, but find the bad guys. We support classes. So we've always, PowerShell was DevOps before DevOps was cool, right? If you go back and read my original Monad manifesto, I talk about wanting to have a single tool that could span the needs of both operators and developers, and that there was conflict when you had different tool sets. Well, in reality, we started off focused in on operators, and then step by step have been becoming more and more friendly to developers. And classes are ways developers like to express contracts and enforce standards, and now they are supported in PowerShell. We have the PowerShell gallery for people to be able to support, publish their stuff and find stuff. We support Visual Studio and Visual Studio Code. Again, developers love this. We have PowerShell Script Analyzer, just a ton of stuff, big release. The biggest thing is we've refactored this to run on .NET Core. Right? This has the full language and all that good stuff, but the commandlets also need to be refactored to run on .NET Core. Okay, so like for instance, Exchange has not yet done the work to refactor to run on .NET Core, so those commandlets aren't there. Okay, so PowerShell.core, full language capability, but not all the commandlets are there. We'll start off and then grow over time. We have added OpenSSH support. So yeah, you like that? So there are two elements to this. So the first is we've announced that we're participating in that. We are committers to that project. We're making changes to the OpenSSH code base. And we're doing two things. First is we're taking OpenSSH, the client and the server, making it available on Windows client and server. And the latest thing we announced is that we're taking OpenSSH and bringing it into the very core of PowerShell and doing PowerShell remoting over OpenSSH. So now PowerShell remoting has had a number of different transports, WinRM, the VM bus with PowerShell Direct, and now we'll support OpenSSH as well. And lastly, now PowerShell version 5 is open sourced, available on GitHub with an MIT license. That means two things. Well, three things. One, you can look at the code, you can understand our code, see how things really work. Two, if you don't like our code, you can change it. You can change it and say, hey, please accept this and ship this in the next version of Windows, please. And three, if we don't do that, you can say, screw you guys, I'm going to take a snapshot and I'm going to build my own version of PowerShell and I'll sell it myself or give it away for free. You can do anything with a MIT license. It's really quite amazing. So that's PowerShell. And we've now made alpha versions available on Mac OS and Linux. So when you talk about a new Microsoft, my friends, this is a milestone in the new Microsoft. Okay? Yeah, it's good stuff. Thanks. I'll just take a moment and just say that, under the leadership of Satya, really things have changed dramatically. And it's the real deal. Sometimes you see these things in the press and you wonder, I wonder. It's the real deal. He told us to get out of your offices, go talk to customers, find out what it takes to make them successful, and do those things. He says, don't worry about the money. He says, if you're making customers successful and we're involved in that, we got smart guys that will figure out how to monetize it. If our customers aren't being successful, it's really hard to monetize that. So just go do what it takes to be successful. And when we did that, what we heard was that people wanted to be able to use any client to manage any server on any cloud. Turns out, that's a really hard thing to do. And when we talked to them, they said, yeah, boy, if PowerShell was available on all my clients and on my servers and could manage any of my clouds, that would be a really valuable value proposition to me. So earlier this week, Google announced PowerShell commandlets to be able to manage their cloud. So now they've completed the trifecta, right? Anybody doing anything with the cloud or data centers is now exposing their stuff through PowerShell, right? VMware, they always have. Great partner. You ever thought you'd hear that? Microsoft saying VMware was a great partner? It's true. They have one of the most active PowerShell communities. AWS, great partner, great PowerShell support. Azure, of course, and now Google. So anybody doing anything does it with PowerShell these days. So next we'll talk about packaging and deployment. So first a word about MSI. Anybody use MSI? Of course, everybody uses MSI, right? MSI is not supported on Nano Server. I want MSI to die. I want MSI to die. Right, exactly. Why is that, right? Well, first, there's two reasons. One is MSI has GUI dependencies, so that wasn't going to work. But the second and more important thing is that these custom actions really are the portal to hell. right? That just transports you right to hell. And why is that? Well, because as much as MSI tried to be declarative, as soon as you had that escape hatch of the custom actions, that's where people put all their code. That's why you can't do offline installs. That's why you can't do offline servicing. That's why you don't really know what's going on. So you know what? Just here's the thing. To be a good architect, you gotta be a butthead. No, you do. You just got to be a butthead. And so this architect, whoever came up with this, is like, hey, this is the right thing to do. Declarative, declarative, declarative. And then somebody said, yeah, but there's this problem. Why don't we just, X, why don't we just have these custom actions and then we'll address that? And when that guy should have been a butthead to say, no, they'll work around it, he said, yeah, you're right. And thus we got a mess. Okay? Kittens. It's a beautiful world. We have this new thing called the Windows Server App Installer. This is based upon the AppX that the client has been using for quite some time. It is a purely declarative installation model. We have taken that and extended it for server scenarios, which are different than client scenarios. So things like NT services, perf counters, COM objects, WMI providers, etc. So again, all purely declarative. No custom actions. What that means is it opens us up to being able to do, first I know exactly what happens. Second, it enables us to do things like offline installation, offline servicing, etc. So really quite a good advancement here. Now, the world, how many people have ever thought themselves when they're configuring a Linux or a Windows server, man, this feels like a scavenger hunt, right? So I got to get this software and it's sort of over here, and I got to get this software and it's over here, and it uses a different set of tools, and this software over there, different set of tools. It's sort of a mess. And so what we wanted to do is we wanted to solve that mess, right? So here we have lots of different package sources. Never mind, we have lots of different package sources. I guess that's just not working. Package sources, be they the PowerShell gallery or a NuGet gallery or a Windows Server gallery. In the future, you'll see web deploy, you'll see all the different things. And then on the right, the left, we want to have a consistent user experience to be able to get that. And so in between those two, we put this new component. We call it an architecture. We put an architecture between these things, and we defined a set of interfaces that then said, here's how people will be able to interact with repositories, and that's this PowerShell Management Core. And then we've worked with people, we've written a number ourselves, we work with anybody to write these PowerShell package management providers that then gain you access to types of resources and instances of resources. So what's that mean? So there's a well-defined way to talk to NuGet, but guess what? There can be public NuGet repositories, there can be private NuGet repositories. This architecture deals with that. In particular, at the end, you get an experience like this. I'd like to find packages. I'd like to save a package, which pulls it down from a repository and puts it into a file system. I'd like to install a package. I would like to get a package to find out what's installed on this machine, and I'd like to uninstall a package. Pretty good world, right? Pretty good world. And you have this experience, whether it's NuGet or PowerShell or Windows Server components or containers. Same experience. Pretty good world. Next, we'll talk about configuration. Of course, configuration management, desired state configuration. This has been the big shift in Windows Server. In the past, it was sort of, again, we just never had an architecture. So some people did things one way, some people did things another way. There's no coherent way to find out what is the architecture or what is the configuration of a component. What are my components? What are the configuration of my components? Are they configured the right way? And if they're not, how do I correct them? Everybody did that their own way. So desired state configuration solves that problem. We did that originally in the previous version of the operating system. Really, that was a version 1.0. That was our first experiment with a minimal viable product. Some people told us we didn't understand the concept of minimal. We went a little bit below that, but that was quickly addressed with the 1.1 release, and that was a pretty good minimal viable product. This is not a minimal viable product. This is a very solid, comprehensive offering, okay? And so the idea here is to shift from an imperative way, do this, then do that, then do this, then do that, and then, oh, well, what happens if there's an error? Do I go back? Do I go forward? Did I catch the error? That whole messy world of imperative programming to more of a declarative model you see here, right? For this node computer name, I want this Windows feature. I want to ensure that it's present. And then I want to have a DSC pull server, and here's the configuration. It's a purely declarative thing. And just like in Star Trek, you get to say, make it so. You say, here's the way I want the world, make it so. You hand it off to an engine, and that engine makes it so, and will tell you if there are any deviations from this, or if it couldn't succeed. It will also, you can configure it to monitor for changes. Hey, is anything, that's the way I wanted the world to be, is it still that way? And if it's not, it will auto-correct it, or you can have it be auto-corrected. Huge advance in the architecture. Desired state configuration is a platform. It is a platform, okay? So the idea is that everyone will plug in their managed resources into that. So managed resources, the hardware vendors, IIS, SQL, all the management things that need to be managed will plug into this interface. And because they plug into that interface, then any management products, my buddies at Chef, they can consume that. My buddies at Puppet, they can consume that. Both of them have done that. They've done great DSC integrations. We are building one as well. That's our System Center and Operations Management Stack product. Any management product can consume this. In the box, you have a scripting experience. A number of people are doing that themselves. Hey, you know what? I don't need no stinking management product. I can script it myself. And you can. And you find out, is that the right thing? Does ad hoc scripting give you what you want? Or are you better off with the product? Anyway, but the key thing is, if you're looking at doing configuration management on Windows, you just need to ask one question. Hey, does that product support DSC? And if they do, you can be assured, oh great, they can manage all the things I care about. If they don't, you have to say, well, do you manage this, and do you manage this, and do you manage this, and what am I going to need next year, and do you have management for that? And basically, anybody that's not any management products that's not supporting DSC is not aligned with the Windows Server strategy, and betting on that product, you're going to end up in the island of misfit toys, right? That's not going to be a happy world for you. But as long as they support desired state configuration, it's a safe bet. This is supported on down level, Windows Server 2002, and on Linux. The Linux support has been there for quite some time. Now let's talk about containers, right? So Windows Server 2016, we now ship with containers. We have two types of containers. One is called Windows Server containers. This is isomorphic to the Linux containers, exact same model. It's OS virtualization, okay? So you're virtualizing the OS. This works for both Windows Server Core containers and for Nano Server containers. And we have a new thing. This is Hyper-V containers. Hyper-V containers provide you the isolation and security of a virtual machine. Okay, so with Hyper-V containers, you can take a container from the Democratic National Committee and a container from the KGB and run them on the same system, and everything's good, right? Not so much with the other one. Not so much with the other one. They're there for friendly multi-tenancy, right? So different divisions of a company use the one. But if you want hostile multi-tenancy, that's what Hyper-V containers really support. Now the benefit here is we took really a courageous decision. Again, talk about the new Microsoft. We had made the decision to support Docker. We're going to support Docker. We were also building our own proprietary management stack. At some point we stopped and we said, hey, maybe we should dump our proprietary stack. And then we said, well, wait a second, what would that mean? That would mean in order to take advantage of this critical strategic technology, containers, people would have to download and install a third-party piece of software, Docker, to manage it. Like, are we comfortable with that? And everyone said, no, 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 no. But it was the right thing to do. So there were quite a few iterations, but in gut checks and like, hey, is this the right thing to do? Before we finally pulled the trigger and terminated our project of proprietary, our Windows-based management, and now our containers are only manageable through Docker. So, new Microsoft. The benefit of this approach now is that all the entire Docker ecosystem will work with Windows containers as well as Linux containers. Indeed, there's a PowerShell project to layer on top of the Docker API. And so I've got a demo where I have two machines, a Windows machine and a Linux machine, and you run exactly the same PowerShell commandlets to manage the containers on those OSs. Then you change the target, because Docker is a REST API, and the Windows machine, you run exactly the same commands, but now they're managing Linux containers on a remote Linux machine. And on Linux, again, PowerShell on Linux, you run PowerShell, you target a remote Windows machine. So this is perhaps the best concrete demonstration of the use any client to manage any server running in any cloud. It's really quite a wonderful world that's coming to you. Lastly, I want to talk about operational validation testing. This kind of puts it in focus. Sometimes you can have things perfectly configured, but they don't actually operate, right? So the example of this is you use a configuration management product and it says, oh, everything's perfectly configured, but somebody didn't plug in the Ethernet wire, right? So it can be perfectly configured, but not operational. And so what we've done is last year we embraced an open source project called Pester. Pester is a unit test framework. First time that Windows accepted a community project and shipped it in Windows. So I don't know if you had that in focus. Community software shipping in Windows. It's a new world. Anyway, on top of that, we wrote a pretty thin layer, said, hey, this is actually work great for operational validation testing. So it looks like a unit test, but instead of testing your code, you're testing the operational validity of a system, okay? So you describe the scenario, you say what it should be, and then you do a test, and then declare what the status should be. And then what you're able to do is you're able to invoke these things, and very clearly they just say, hey, this should be running, this should be running, this should be running. And the idea then is that if anything ever goes wrong, you run these operational validation tests, and it tells you what's working and what's not. How many of you have ever, here's a great kind of gut check. It's Patch Tuesday, you just patched all your servers. When do you get to go home? When do you get to go home? The answer is, who knows, right? You just hang out by the phone and wait to see if things blew up. Well, that's kind of a crappy world. Imagine instead you did a Patch Tuesday, and then all your systems, you were able to run tests that says, hey, yep, here are all the things that should be running. Hey, they're all running. Then you have some knowledge, like, okay, seemed like that was good. Now, if it turns out you go home and you get a phone call, then you say, hey, I don't want that to happen again. What did I miss? Let's go write some more operational validation tests so that I never get called at night. Wonderful world. Okay, so DevOpsification of Windows Server. I've talked to you about componentization, packaging and deployment, configuration, containers, operational validation testing. There's quite a few more things that we've done, added architecture to address these issues, just didn't have time to talk about them. The key message here, however, is that Windows Server 2016 is architected to make DevOps easy. Huge investment, company-wide, make DevOps easier. The components in orange here are the ones are available down level. So we did this work first in Windows 2016, but for the packaging and deployment, the configuration and the operational validation testing, these are available down level as well as part of the Windows Management Framework. So again, why did we do all this? You can see, you connect the dots. I'm always a big fan of why, so you understand why we did it, why you can be confident that we will continue to go down this path. Why did we do this stuff? Because these are the things that help us be cloud competitive. We want to be small, Nano Server's small, it's very fast, boots in like 2.5 seconds, yikes, very fast. It's very secure, right? And it is optimized for DevOps. So let's talk about some of the specifics. Security improvements, the number of drivers loaded by default goes from 98 down to 73 The number of services running go from 44 down to 25, and the number of ports open go from 26 down to 11. Huge decrease in the security attack surface of the OS by default. Now, if you end up saying, oh, for my application, I need to add this and add this and add this and add this, and these all go up, that's fine. Your security risk goes up, but it goes up because you're using those components. The problem was, if you weren't using those components and you still had that security risk, that is the thing that we've eliminated, okay? Now, resource utilization, process count goes down by about 20%, from 26 down to 21 by default. Here's the Azure guys love these, right? Number of megabytes to boot goes from 306 megabytes to boot down to 108. So if you have to boot a bunch of VMs on a machine, you power cycle or whatever, and you got to boot them all, this happens very, very quickly. The kernel memory in use goes from about 140 down to 61. That means greater VM density for you, more memory available to the application. And the deployment servers, just put your seatbelt on. This is just crazy stuff, okay? The setup time goes from 300 seconds to 35. Yesterday we were talking about, in the open space, talking about, oh, hey, should I do a slow cycle or a fast cycle? And I said, you know what, it's a function of the cost of performing an operation. Wait till you see this tomorrow. I don't know where the guy is, but here's what I was referring to. Setup no longer takes 300 seconds, it takes 35. The disk footprint, server core is about 5 gigabytes. Server and a desktop takes about 9 to 10 gigabytes. Remember, server and a desktop, it makes me sad. 10 gigabytes, pretty sad. But server core is about 5 gigabytes. A nano server is 4.6, and the VHD size from about 6 gigabytes down to 480 megabytes. 480 megabytes. Windows Server and 480 megabytes. Stunning stuff. Microsoft has really been kicking it in the cloud space. Gartner has this idea of a magic quadrant that says who has the great vision and who has the ability to execute on that vision. Microsoft is the only company that is in 6 of Gartner's magic quadrants, right? So those are x86 virtualization, public cloud storage services, cloud infrastructure as a service, disaster recovery as a service, enterprise application platform as a service, identity and access management as a service. Here's the point. Yeah, there are other people out there in the cloud and they had an advantage and they were ahead of us for quite some time. Microsoft is coming on strong in the cloud. We're executing very well, and you should take a look at our Azure and Azure services. It's just awesome. When we have Windows Server 2016, we're going to go farther up to the right. Okay. There's a lot of information here. Doesn't really relate to DevOps. However, there's one data point that I just can't say enough. Windows Server 2016 will support 24 terabytes of RAM. 24 terabytes of RAM. Like, let's let that thing sink in there. 24 terabytes. Anybody got a 24 terabyte disk drive? No, they don't exist. Anybody got a 24 terabyte disk array? Probably a few of you. But this is 24 terabytes of RAM. Man, I just can't say that enough. It makes my mouth feel, I like it, the flavor in my mouth when I say it. The virtual machines, you can have a virtual machine with 12 terabytes of memory. A virtual machine with 12 terabytes of memory. Now you might look at it and say, well, who needs that stuff, right? And the answer is Azure, right? We do this stuff for Azure. Now, why would Azure need something like this? Well, there are things like SAP HANA or Hekaton, if you're familiar with Hekaton. Hekaton is an in-memory database. So imagine if you had an in-memory database with 12 terabytes of virtual memory. Like, that's a good world, okay? So now, Azure will be able to host things like that. And the virtual machines, now you can have 240 processors in the virtual machine. So I'm telling you, it's Windows Server 2016. I'm just talking to you about the DevOps stuff, but the OS itself is just rocking. You should go take a look at it. It is an amazing release. So I mentioned to you, and it is true, DevOps really is about culture and processes, right? If you get tools and technology right, but don't get the culture and processes right, you're not going to get the benefits of DevOps. However, tools and technology can make DevOps easy, or it can make it hard. Windows Server 2016 is architected to make DevOps easy. Giving you just a small slice of that here today. So here's my contact information. Thank you very much for your time. Appreciate it.